Alright, so I believe I'm recording. Let's take a look at this problem number 6. Find all sets of 3 consecutive even integers whose sum is between 441 and 459. So first of all, make sure you understand what the set of integers are. The set of integers could be negative numbers like, -3, -2, -1. It could be 0, or it could be positive numbers, 1, 2, 3, 4, 5, and so on. Fractions are not integers. 1/2 is not an integer. The square root of 2 is not an integer. Pi is not an integer. Okay, so what does it mean to be consecutive? Well, consecutive means that right after that it follows right after another. If people are consecutive, or if the numbers are consecutive, they're right next to each other. Now, even integers are divisible by 2. So -2, 0, 2, 4, those are consecutive even integers. Negative 2 and 0, I should say that the consecutive if you have a pair of them. -2 and 0 are consecutive. 0 and 2 are consecutive, one after the other. So let's draw a number line. Let's let x be our smallest even number in our list. Small numbers are to the left, larger numbers to the right. Integers have a property that even and odd alternate. If this is an even number, then the next consecutive integer is odd, but consecutive even, the next even number that follows this is x plus 2, because right here is x plus 1, and that's odd. Well, x plus 3 is odd, but x plus 4 is even. So we're letting x be the smallest of these even numbers. Now, this sum is misspelled. It should be SUM, sum, and that means to add these up. So our sum of these 3 consecutive even integers are x plus 2 plus x plus 4. So 3x plus 6. Okay, and that's the same 3x plus 6 we had on the previous problem, but this number is even, whereas the last one was going to be an odd value. Now, this sum is between 441 and 459. So when it says between, I think of it as strictly between. In other words, this is not 441 less than or equal to. It is not equal to. All right. So step by step, I need to get this x by itself. So the first thing I'm going to do is get rid of this 6, positive 6, by subtracting 6. So I'm going to subtract 6 from each part of this compound inequality. 441 minus 6 is 435, I believe. 459 minus 6 is 453. Let's divide each of these numbers by 3. 435 divided by 3 is 145. 3 divided by 3 is 1, and 453 divided by 3 is 151. So all I did was just divide everybody by 3, right? All right, so now let's interpret what this is, what this means. We have more than one possible value here for x. If I draw a number, since these numbers are so close to each other, I'm going to draw a number line, and this is 145. Now, Remember, x is even, so it couldn't be 145. And 146 is bigger than 145 and smaller than 151, so 146 is a possible value for x. 147's not. 148, that's an even number that's between these two values. 149 is odd. 150. 150 is an even number that's between these two values. Then we've got 151. So those are the only even numbers that are between 145 and 151. Now I need to shrink up to give myself some room here for the rest of the problem. Alright. So it wanted all sets of 3 consecutive integers. So if x is equal to 146 as one possibility, I come up here to what I've shrunk, then x plus 2, 148, and x plus 4 is 150. So that's one triple, and it's not a pair of answers. That's one set of 3 answers. If you add up these 3 values, it'll be between 441 and 459. Now there's another set of 3 consecutive even integers that also work as well, and that's 100. We use 148, and then we add 2 to that, 150, and if we add 4 to 148 or 2 to this, 152. There's consecutive even integers. 148, well, the next larger even integer is 150, and the next largest even integer is 152, and if you add those up, it's within this range of values. It turns out we have another set of 3 that also satisfy that. So there's our 3 answers. We've got one set that is 146, 148, 150. That's one answer. Then a second answer, 148, 150, 152. Those are consecutive even integers. 150 follows as the next even integer after 148. And then we've got 150, 152, and 154. So that's our set of 3. Hope that helps, and I'll talk to you later.